So once we have validated our skill through confirmatory factor analysis and then exploratory factor analysis, whichever works in our way, the next thing is that we have to come and confirm that the data that were collected about that variables are okay or not. And that is what we call reliability. I can ask you, how old are you? You will tell me that you are 500 years. Is 500 years not a data? Can't it be age? But does it reflect your true state? Good. So when you give people skilled items, they are more likely to also give you some kind of data that will not be more useful. For instance, all of them may be taken, you have a range of 1, 2, or 5, and all of them may be taken 5. Imagine you are sampling about 700 people in your study, and for a particular question, everybody is taking 5, 5, 5. Is it really the case? Singular response on a particular item by all the sample, it doesn't make logical sense. So perhaps maybe those who went to collect the data, they did not really do proper data collection for you. You go and sat behind the mango tree. Okay. So since our data file may be tinted with some errors, it is important we try to check if the data file is also okay. Because if you have erroneous kind of data file and you use it to analyze your objectives, your results will not be believable. Is that not it? That's why we have to come and confirm if the data is reliable or not what? Reliable. And we have so many approaches that we can use to test for the reliability. In the SPSS, we have so many of them, but I'm going to teach you one, which mostly go with cross-sectional data. And that is what we call internal consistency. So we are going to use the internal consistency approach to measure reliability. The internal consistency approach to measure reliability. Internal consistency approach. Okay. We have so many approaches, but the one that we are familiar with, the one that I want to teach you. If you are interested, you can go and learn the other approaches as well. Okay. Now, the internal consistency approach uses a proxy measure to detect if your data is reliable or not. And that proxy measure, the name of it is what we call Cronbach's alpha. And when you compute for the reliability of a particular skill, and you get the Cronbach alpha of 0.708 and above, 0.708 and what above, so it should be greater than or equal to this figure. You conclude that your data is reliable. You conclude that your data is reliable. You conclude that your data is reliable. So like the validity, which we computed for each of the variables, each of the constructs, the reliability must also, we have to do for each of what? The constructs. If you do the reliability for all of them, it doesn't make sense, that's not it. Because they are different variables belonging to different factors or constructs. So you don't have to put all of them together. But most of the time you see people, they do overall kind of internal consistency, which is not. Because financial integration is different from operational performance. Financial performance is different from customer integration and all those things. That's not it. So you have to do for each of the respective constructs. So that is it. Now let's see how we can illustrate it with the software, with the SPSS.